is going to be lesson 14, which is going to be, I'm just titling it orbital notation. It's really the second half of the last lesson. It's just that I just felt like it would be overwhelming having too much new material, plus the new way of submitting it with the photo. You'll notice this lesson looks almost identical to the last lesson. Basically what I've done, I'm just to simplify things as much as possible. You're going to do the same thing as yesterday, where you're going to submit a picture with 4 different questions, and it's actually the exact same 4 elements. It's titanium, aluminum, silicon, barium. This time, though, instead of drawing the electron configuration, you're going to do orbital notation. So the slides from yesterday, I'm sticking on these. It's the same slides. And I'm just going to go to the bottom, the parts that I didn't cover last class. And so you do electron configurations, and then we get to something called orbital notation. What orbital notation is a very similar idea, except for this time, we show where the electron is. So what we do, instead of just writing an exponent to say how many electrons we have, we draw an orbital, and then we draw an up arrow for each electron. Or I'm sorry, an up arrow and a down arrow for each pair of electrons. So an up arrow and a down arrow represents 2 electrons. So as we do this, you'll notice Hund's rule, which means that you need to put 1 electron in every orbital before you start doubling them up. And I'll demonstrate that here. We'll do these 3 examples. I might have to do a couple other examples. Yeah, I'll do this one as well. So we'll do these 4 examples. So the way this orbital notation is going to work, let's do hydrogen. So we have hydrogen. Z equals 1. So this time we start off at 1s. But instead of you writing a 1, before you'd write a 1 right here to say there's 1 electron at 1s. Now instead of that, you're going to draw this to represent the orbital, the single orbital we have at 1s. And then there's only 1 electron. So draw a little upwards half arrow. So you're saying there's only 1 electron of 1 spin sitting inside there. So let's move on and do the orbital notation for helium. So now for helium, it's going to be a similar situation. We're going to have 1s. So now it's going to be helium, which has a atomic number, or has 2 electrons. So now you'll do 1s. You'll have your first electron as an up arrow, and your second electron as a down arrow. 2 electrons total. Okay. Now let's move on and let's do carbon. So for carbon, I'm pretty sure that's the question I had on there. So carbon, yeah, we're going to do carbon, and Z is going to equal 6. So we'll have carbon, where Z equals 6. So watch how we're going to do this. We'll do 1s, draw the orbital, and we have 2 in there. Now we go to 2s, draw the single orbital, we have 2 in there. Now watch what's going to happen. Remember, when we get to 2p, how many electrons fit in p? Last class we learned it was 6. 6 electrons belong in p. So 6 electrons fit in a total of 3 orbitals. So you're going to have 3 total orbitals. Remember, when we did this, we found out that when the sublevel is 1, when the sublevel is 0, which we call S, you do 2L plus 1 to find how many orbitals you have. That didn't matter as much last period or yesterday, it matters today. So L is 0. To find your number of orbitals, you do 2L plus 1. Remember, 0 times 2 plus 1, we only have 1 orbital. That's why at S, there's only 1 orbital. But when we go to sublevel 1, which is P, it's going to be 2 times 1 plus 1, we get 3. So at P, you're going to draw 3 orbitals. Now think, how many electrons do we have left to deal with? We had a total of 6. We've used 1, 2, 3, 4, and now we need to do 5, 6. So put 1 here, and now I want you to think about, are we going to put the second one in there, or do we space it out and put another one over there first? That's what that Hund's rule is that was at the bottom of that slide. Every orbital gets 1 electron before you begin to fill them. So since we have to have these extra orbitals, because every p comes in with 3 orbitals, you need to put electron number 6 right here, and that would be the final orbital notation. It would be a mistake to do this. When they can, electrons will get away from each other. I mean, it'd be kind of like if you go into a new house, right? Say you move to a new house, and there's all sorts of rooms in there. you and your brother aren't going to go get the same room when there's 3 or 4 empty rooms. You're going to fight over who gets the best room. So that's how it's going to go. You get in there, everyone's going to get their own room before they start doubling up. Okay, let me do one more example, and then I think you guys should be able to do this. So we'll do manganese, Mn, which is Z equals 25. So we'll do 1s. We'll do 2s. We'll do 2p. And then after 2p, we'll have 3s. And then 3p. Let's see how we're doing so far. That's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18. So we got 7 left to deal with. So now let's remember what comes after 3p. Remember, you do 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. And remember, you do diagonal lines. It's 2p and 3s. Then it's going to be 3p, then 4s. So after 3p, we're going to go to 4s, give it 2. Then next up will be 3d. Remember the diagonal line rule to determine the order. So the last thing we have here is 3d. Now, d sublevels, let's look at this. D sublevels, so sublevel 2, which is d, are going to have 5 orbitals. And lastly, if we did it, F would have 7. So for this one, we're going to make 5 orbitals. 1, 2, 3, 4, 5. And think, how many electrons do we have left? We've gone through 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've gone through 20. We needed to use 5 more, and we've got 5 orbitals. So don't double up in the first 2. Give everybody 1 electron. Each orbital gets 1 electron. And then we're actually done. If we had 5 more, we'd go ahead and double up and move on to the next sublevel. So that's how we do orbital notation. So for this assignment, keep it simple. Just do the 5 orbital notations that I've given you there. Same thing as yesterday. Make a picture, turn it in. If you're having trouble with this picture situation, please email me. If you didn't do yesterday's assignment, you could, since it's just the same 4 elements doing 2 different things. If you didn't do yesterday's assignment, please talk to me. You can make it up today. It would be easy to do both at once. So just let me know if we're having issues and try to get this in by 5 o'clock today. All right, have a good day. I will talk to you guys soon.